on this computer. All right. Everybody can see even online. Here, we'll go through the so this is night one. This is at Rudy's seafood restaurant, which is one of the specialty places. That's their seafood stew. So this is up in the first class lounge area. There's from the Lido deck. This is probably where you saw all the fist fights on Carnival. Down over there. So this is the Star Princess. This is their Princess Cruises brand new ship. I don't go in these pools. That's for the lessers. Of course, I did Peloton training every morning. Oh, that's just priceless stuff for the oh, here's some of their Christmas drinks. Santa hat. This is on recording at Concordia. It's dry campus, don't drink here. Yeah, that's one of them. I like the name of that tequila, Panelones. I had to go buy that one really quick because chances are if it was a text message I took a picture of it, it doesn't have good stuff on it. Yeah, this is that butcher block place. Oh, look, there's Mr. Gonzalez. This is if you see the little guy on my shirts, this guy. That's Mr. Gonzalez. This is the actual guy. So he's been to every continent, including Antarctica. He travels the world with my wife and I. I don't know, that might be like Honduras or something. There's another pool. That's also, I don't go in that one either. Oh, there's like the fancy coffee shop drinks. Oh, that's my door. Hold on. Look at my Ninja Turtle. So my wife does it's called diamond painting. Where they put these little diamonds on something. I know she does it for hours. So this is a diamond painted Donatello, but all the rest of these are her stuff. This was actually the bad day. I made her move this up to here so I could see it better because this is below my height. Oh, see, this is that security thing. I told you that they you know how far to stay away from the ship. Because they had guys with like guns and stuff out there to make sure when we were at this island, there weren't pirates or something. Oh yeah, see, here's my elite lounge. Yeah, I don't. All right, though this is the beef tartare at Crown Grill. That's raw beef. I got 3 orders of that every time. So good. Well, that's why I got 3 orders, and this is an appetizer. This is yeah, you know, you go to the buffet at Carnival and it's like I'll just have some of the blue and a little bit of the green. That's a reference from National Lampoon's Las Vegas Vacation. That's the crab cake. There's the porterhouse. Now that's my pool. Well, no, I mean that's the that's behind a swipe. This one. Yeah, that is a hot tub. Yeah, this is a hot tub with these you know jets coming down from the top, so you stand underneath it, get your shoulders for like an hour. Oh, there's my wife. That's the warden. You know, she was supposed to be dead a year and a half ago. They gave her 2 years to live 3.5 years ago. She's still cooking. She has bladder cancer. Let's see. Oh, there's the um yeah, this is Crown Grill, the steakhouse. Oh, there's more of those beef tartares. No, yeah, we rarely get off the ships. The only time we get off the ship is if my wife wants a picture of the whole cruise ship and we need to get further away from it to get it all in frame. That was our balcony. Look how big that balcony is. Oh, here's the sushi place. That's my view from my table at the sushi place. No, they're all over the ship. I mean, the ship is 1,000 feet long, 200 feet wide, 20 stories tall. Oh, there's the sake menu. Oh, there we go. You can't beat that sunset. There's the seaweed salad from the sushi place. That was the miso soup. There's my sake, shrimp rolls and stuff. Now, this is my wife's favorite place. There's a famous artist named Brito, and there was a restaurant on there called Love by Brito. That everything was based on his art. Um, even you see the napkins are shaped like hearts. This is what his artwork looks like. This I think I have a picture of. Look, even the forks have a little heart on them. The knives. Yeah, this is like one of his things of art. Look, even the garnish on the drink had a heart on it. The bread was a heart. The butter says love. Yeah. Here's an oyster, and it had a heart there, and I think maybe they were trying to do the heart out of this gold. I don't know. Yeah. More hearts. Even the wine said love on it. Oh, this is my Wagyu beef there. They don't have that on Carnival. Hey, look, I'm not judging you, but sort of. All right. Well, so let's call that. Oh, here I'll pick and choose a. Oh, this is Sanchez. I talked to him for a while one night. Oh yeah. So that's my setup at an island. So I sit there. This is my flower Chardonnay, my Coke Zero, my laptop. So I was working on a lot of my writing or coding stuff, and this is my view. This is Bellini Bar when we were at port. Isn't that a good office? All right, let's get cooking. He doesn't have any pictures from his carnival. He's blacked out the whole time. All right. So this is coding two. The syllabus and all that crap should be up. Punchline. Um, uh, I think it's 60% of your grade is homework, 40% is midterm and final. Same policy as last semester. If you do better on the final than you did in the midterm, I'll replace your midterm exam grade with your final exam grade. Um, um, Homework is practice for the big game. I'm going to grade it pretty easily. You need to put in the reps. I'll find out on the exams if you're not getting what you need to get out of it. Um, be prepared for things to be a little more difficult this semester. In fact, week one is you guys are gonna hate me starting week one. We're gonna be doing merge sort. Did we talk about merge sort last semester? Oh my God, you're gonna drop merge sort. Just go up to a senior and just say merge sort. Is that who? You'll get a reaction from every senior. It's not bad, but recursion is a difficult topic for beginning programmers. Yeah, so any question on grading? Pretty straightforward, the usual shtick. All right. So let's talk about recursion. I will weave in some stuff from last semester as like review stuff because I realize all of you definitely coded all break, right? Or did everything?
I did.
You did? Oh, good. You got a Steve Jobs thing going on these days. I like it. It works. It's way better than last semester. Last semester was not good.
What about last semester?
It's like my teacher's hazing me day one. All right. So anybody know what recursion is? Oh, Carnival. Okay. Okay. So recursion is when a function calls itself from within itself. All right. And as you said, hopefully that recursion eventually ends. We're going to be talking about the consequences of recursion here in a second. But let's just think about an example. Certain problems lend themselves to recursion. Now, first of all, recursion and iteration, like for loops, are sort of kind of in a similar category where we are accomplishing repetition. But the mechanism by which we're accomplishing that repetition is different. And it comes with a consequence. Now, first of all, we can just blanketly say anything we can do recursively, we can accomplish with a loop and a stack data structure. You'll learn how to write stacks next semester. They're not difficult. We might even write one this semester because we accidentally stumble upon them. But a stack data structure, we talked about linked lists a little bit last semester. We have these ideas of linked data structures, and we talked about them in the context like when we talked about arrays. Remember? So an array is a fixed. So let's just throw arrays back in here real quick. So we're going to say array versus linked list. And really, linked list, I want you to kind of mostly put that in next semester for coding 3. But it's an important concept for maybe us to just know about because we're going to kind of accidentally be using linked list a little bit in here, but we won't be like writing them from scratch. By the time you get to coding 3 and you are introduced to writing a linked list, you're going to be like, oh, isn't that just like our dungeon where a room connects to another room? It's the same crap. All right, so arrays are fixed length and exist in contiguous memory. Okay, what does contiguous memory mean? Carnival. Yep. So contiguous memory is memory right next to each other, right? So when we build an array, so for example, if I say int array AR is equal to a new int array 10, something like that. So this will work in Java, C#, C++, and C. It won't work in C actually, but whatever, the syntax. So for those of you who haven't had me before, I think there's at least a couple people in this class, they might be online. I teach programming from the perspective that the language doesn't matter. So we're going to keep jumping from language to language. Last semester we started with Python, then went to Java. This semester we're going to start to Java. Who knows where I'll go from there? Probably C#. We might throw some other interesting stuff in there. Yeah, that's the point. All these, once you have programming as a skill set, learning a new language doesn't take long. You know, how do human beings solve problems? Okay, so we ask questions, we have to remember stuff, and we do repetition. That's how we solve problems. 100% of programming languages have facilities for those 3 things. Remembering crap, we have variables. So if you are introduced to a brand new language, you just say, how do I define a variable in this? In here, it's int a equals 7. In a loosely typed language, it might just be a equals 7 or var a equals 7. That's JavaScript, right? There's going to be some way of creating variables in every single language. So figure out, what does that syntax look like? There is going to be some way of asking questions, usually an if statement, right? Python, it was an if Boolean expression, then you put the little colon thing, pressed enter, and had to indent. Java, it's if some Boolean expression, you had your opening curly brace, your ending curly brace somewhere, and all the crap in the middle. So you just ask yourself, how do I ask a question in this language? What does an if statement syntax look like? Right? Lastly, repetition. How do I write loops? What does a for loop look like? How do I write functions? Functions are things we can call multiple times, so that's a form of repetition as well. So how do I write functions in this language? Do I need a return type? Function name? What do the parameters look like? Is this a curly bracey language, or is this an indentation language? Python's an indentation language. Most of our modern languages are curly brace based languages. So once you've answered those 3 questions, how do I write the syntax in this particular language? Using that, all your other programming skills align. You can start writing code in that language. First thing you do is you write a hello world program, so you know you have a functional program, and you figure out, how do I run programs in this language? Once you have that, now you can code in that language, no problem. Okay, so bouncing between languages is not a problem. The idea of somebody saying, oh, I hate Java, like some look, it's okay. We're working through it. This anger management thing is a thing. It's tough. I get it.
I had trauma.
Java PTSD. Wakes up at 4 a.m. screaming, there is no closing curly brace. What do you mean pointers don't exist? So language doesn't matter. We're learning to program. That's why I'm going to bounce all over the place. What's that going to let you do? It's going to let you take whatever newfangled stupid language comes out next week, because, interpreted languages, loosely typed interpreted languages are a dime a dozen, because you don't need to have a compiler. Compilers are difficult. Remind me, what's a compiler? Go ahead.
Files the language before version machine code.
Okay. So a compiled language is a language that prepares the executable before we run the program. So it's we prepare it prior to runtime, where an interpreted language gets executed in order during runtime. So there might be a performance difference between those two, right? The one that we set everything up ahead of time is probably going to have less overhead during runtime, but computers are really, really, really fast, so it doesn't matter. Most of the time, it doesn't matter. Okay, but a compiled language, the idea of a compiler, that piece of software, what it does is it takes your high-level code like Java or C++ or Objective-C or C or C#. It takes that high-level code and it turns it into a low-level language that can run on the CPU of that computer. Okay. Now, when we say that a compiler needs to know about your operating system as well as your architecture, what does that mean? So we just learned what a compiler does, right? A compiler takes your Java program and turns it into Java bytecode, which runs on the fake Java processor. Your .NET program, your C# program, compiler takes your C# code and turns it into missile code. Anybody, have you heard of missile code before? MSIL? Because remember, C#, brand new language. He let us know that when I mentioned Java, then I said C#. He said, oh, totally different language. Isn't that what you said?
No, I said
same language. He said it was the same language. So if Java uses a compiler that turns the code into Java bytecode, and which is an assembly language looking program. What's the difference between an assembly language, a low level language, and a high level language? Okay. How they talk to the CPU. A high level language, we write one line of code, system.out.println, hello world. And that would translate into a whole bunch of instructions on the CPU. So in a high level language, one line of code translates into many instructions to the CPU. A low level language, every line of code translates into one instruction to the CPU. So low level is a one-to-one relationship with the CPU. High level is a one-to-many relationship with the CPU. Okay, what's the CPU? Okay, stands for Central Processing Unit, but what does it actually do?
Processes information.
Process these. So we're slowly getting somewhere. Okay, help me understand what a CPU is. I bought a computer. My computer has a 3 gigahertz CPU in it. What does that mean?
It takes an input, gives an output.
Okay, it takes an input, gives an output. How does it give that output? What happens inside that CPU when something's fed into it and something comes out of it? What's happening in the middle?
That code comes in hardware of the computer.
Okay, so what are like if we remember here, let's get back to an example here. Let's do Linux. Hello world. Oh, I want to say assembly. Let's get this guy back up. Ah, remember this guy? Remember this guy? Who wants to explain this code to me? We all remember this from last semester, right? Week 1, week 2. So first of all, this is low-level code, right? So this is a low-level language. So this is assembly language. Specifically, this is Intel-based x86 assembly. All right, so this would be a superset of x86 assembly. This is probably 386, Intel 386 architecture assembly. They had x86, then they had the 286 processors, the 386 processors, the 486 processors. 586 were actually called Pentium processors. Now we're up to Core i7, yada, 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 whatever, Core i9s. Each one of them has an architecture in it, and that architecture is backwards compatible with older architectures up to a point. At some point in there, when you have your next upgrade, you say, okay, well, we're killing something that used to be a thing, but now we have a better thing, right? So that's why if you run, when you buy a piece of software, not that you ever look at this, but it'll have like the minimum system requirements, and it might have on there what's the minimum processor. That's not just for speed. That says, here is the minimum processor that will understand the instructions that the executable of this program relies on. Make sense? After that, there's a speed thing, right? It's got to run fast enough. So when I say we have a 3 gigahertz processor, that a hertz is you can think of a hertz as a number of instructions per second. So 3 gigahertz is 3 billion instructions per second. That's pretty fast, right? For most things as humans, that's a lot. But imagine, remember, high-level languages have a one-to-many relationship with the CPU, which means that when we take our operating system, for example, or some gigantic video game that's written in C++, a high-level language, and it has millions of code, or at least hundreds of thousands of lines of code of high-level language, hundreds of thousands of lines of C++, and every single one of those lines translates into a bunch of lines of low-level code, right? So, I mean, keep in mind, what we're seeing here is hello world in x86 assembly for the Linux operating system. So this is effectively printf hello world. One line of code translated into what, 12, 15, whatever, I didn't count, but ish lines of code. And this is still using power tools. So if I pause for a second, go back to the question I asked a few minutes ago. What does it mean for a compiler to be reliant on the architecture as well as the operating system? Why is the operating system important? What is an operating system? Man, I've forgotten so much stuff since last semester. I need you all to refresh me. I told you lots and lots of. What's an operating system? What job does it solve? Go ahead. Okay. Why do we need it to manage our hardware? Who's using the hardware? We are, right? So remember, the job of a programming language is to allow us to tell this dude what to do, right? Because we're the boss, even though sometimes it doesn't feel like that, right? Especially now with AI, it doesn't always feel like we're the boss, but we're the boss. As software engineers, we're telling this dude what to do. Okay, so we're going to wield a programming language in order to do that. And because we're real programmers in here, it doesn't matter what that language is. We could pick up any sword, kind of get the weight, feel it swinging around a couple of times, like, well, okay, I'm good to go. Let's go to battle, right? So we're wielding a program. We're code slingers. Any of you read the book series Gunslinger? Stephen King? So we're code slingers instead of gunslingers. Gunslingers, they were like awesome with the weapons. They could make bullets curve and stuff. Take out a room. It was awesome. Okay, but we're code slingers, and we wield programming languages to tell computers what to do, so they bend to our will. That's a superpower. Okay, and I've told you last semester, I told you coding is hard. It's hard to get to the point because we've spent our entire lives telling humans what to do or interacting with humans. We have that skill set. We have not spent our whole lives telling a computer what to do. And if we're talking to a computer through its CPU by way of its operating system, we have to have a different level of problem solving. We have to be able to break problems down into smaller pieces. We need to solve the problems in terms of the tools that are in our toolbox, as well as the things that the computer is capable of doing. So we have to learn a whole new alien race. We already are working with humans. Now we have to work with this computer thing that knows how to do different stuff. So we have to learn where the fence posts are, what are computers capable of doing, and how detailed do I need to break my problems down into so I can ultimately unambiguously tell that computer what to do. Computers are, with humans, we can be a little ambiguous, right? We can beat around the bush. We can give them kind of rough instructions and they can probably fill in the blanks. Computers really can't do that very well. With AI, they're starting to be able to, when we're talking about agents and stuff, they're starting to bring semantic meaning from natural languages. So there's aspects of us being able to tell a computer what to do now through these large language model agents. Now, that's not going to replace coding, because sometimes we need to be precise, right? Think about war. Sometimes we drop the bomb. Sometimes we go in with daggers, right? There's not one fit for the right tool for the job, all right? So AI is not going to replace you. AI is going to replace aspects of what software engineers do. I mean, where I use AI for coding stuff is for all the grunt work. I mean, I've been coding for a while. I started coding when I was 9. So that means I've been coding for almost 40 years. I'm decent. I got a pretty good background in this stuff. It's not a great use of my time to spend 20 minutes writing the skeleton code for an API. That's something that is not a challenge for me. It's just time, right? It's the same thing as any menial task that you've been doing your your whole life. Some things just aren't a great use of your time, but you have to do it anyways because you don't have any sort of automated machine to do it for you. Until you do have an automated machine to do it for you, and then you start using that, right? You don't go into your backyard and light a fire every single time you want to boil water, right? You got an oven or you got a microwave, whatever, you got tools to accomplish this, right? So it's not going to fully replace us, but I use AI to quickly generate aspects of a program, and then I go in with darts. I fill in the details. I might even use AI for, if I say, okay, right here, I want to insert this image into this HTML thing. Sure, I can write the HTML tags to do it. But if it's going to take me a minute to write that code and AI can do it in 10 seconds, I just save some time, right? But I get very precise when I use AI when I'm coding. The IDE I use is called Cursor, and I pay for Cursor. But Cursor allows you to talk to the agent as a whole. So if we just pause for a second, and we talk about large language models just for a second, because I want us to get this into our world of coding. Because one concern that software engineers have today is that, our jobs are going to all go away. You're going to start making more money as long as you can now wield AI and the programming language. Okay, so if I, just to put some stuff in context, so if we do large language models, what are some large language models you've heard of? I'll get us started. ChatGPT, right? Gemini. So Gemini is Google's, right? Okay, what else? Huh? No, that doesn't count. Oh, okay. Actually, it'll work for my example. Snapchat AI. That's fine. That works for my example. I'm going with that. What else? Llama. Okay. Oh, Meta. Yeah, DeepSeek. Chinese one. Okay, Grok. That's Elon Musk's. Llama is Meta's. You're missing a major. You're missing one of the big three. Well, actually, we'll put Copilot as one of the big four. Replit. Yeah, we know every piece of software and their brother now has little built-in AI stuff. We're talking about the big boys. All right, Claude. All right, so our big three, I'm going to go ahead and I'm going to move Claude up here. I'm actually going to put Copilot right here. And the story we're going to tell with those top ones is the same story that fits into all these. But we want to understand, especially now that we're swimming in a pool where every single thing we open up has an AI something or other. Zoom has an AI something or other, right? In fact, I used it yesterday. We've been doing interviews for new faculty members. We're adding one faculty member to computer science. And you've heard me say this before, but I'm going to prove it to you. So I've mentioned that even you get people who are out in industry and programming, they don't know the simplest stuff because they didn't learn how to program correctly. They didn't learn how to wield any sword. They learned Java or Python or whatever, and only enough to solve the problem in front of them, not to wield it on any field of battle, right? Okay, you're learning how to do that in here. So, I got off my Gemini Copilot. Oh, interview. Yeah, thank you. So we're interviewing people with PhDs in computer science. So first of all, a PhD does not mean you're smart. Hardest degree I did, period, was the bachelor's degree, the degree all of you are working on. By far the hardest degree, because I had to take a whole bunch of classes that I wasn't interested in. Psychology, sociology, insert least favorite class, right? And I went to school back when there were math requirements for computer science. So I had a math minor because the number of math classes you had to take for computer science was one short of a math minor. So I had a math minor, but I was good at math. I was good at computer science. Those were not my hard classes. You know, those were the classes I looked forward to. Sure, I learned stuff, but that stuff already kind of was in my wheelhouse. I had to work at the English class or the sociology class or the psychology class or whatever. You all kind of are in the same, we're all seeing the world the same way right now. The bachelor's degree is a hard degree because it's not focused. By far the easiest degree is the master's. Every one of you should get a master's, especially now that the bachelor's degree has become the new high school diploma. It's unfortunate, but higher ed has become a business. Everybody's got to go to college because that's how you get a job. Well, if everybody goes to college, all of a sudden what's coming out of college is entrusted by industry. So now you got to come out of college with something more than you used to come out of college with. So now you need a master's instead of a bachelor's. It's a racket. Spend more money. The way the world works. Now it's taken over our education too. I don't agree with it. I think grades are stupid. It's more about competency than labeling some grade, but it's the way the world works. So we're interviewing people for this job. Our interview has 10 questions, initial questions, things like, how is your teaching philosophy align with Concordia's mission statement? Things like that. How would you explain, real question. How would you explain the idea of recursion to a student who is struggling with this topic? Recursion is a tough topic. It's not hard once you see our example here in a few minutes. Recursion is not difficult to understand when you see it. It's hard to start getting yourself to think recursively. Once you get it, you realize that, oh, this is just another tool, just like any other tool. You have to take a couple things into consideration. But one of our questions, and this is going to be close to a quote, is if a student was struggling with the concept of recursion, how might you go about explaining this to them? We interviewed 2 candidates yesterday. Both have PhDs in computer science. Neither of them were familiar with the concept of recursion. Question, what was it? 11. Tell me the difference between ASCII and Unicode. What's the difference between ASCII and Unicode? We talked about it last semester, right? Go ahead. Okay, well, what are ASCII and Unicode? What problem are those 2 things solving?
A binary number to play a character.
Okay. It's mass. Yeah, so it's a character set where we have a list of characters that exist, right? So ASCII has 128 characters. Extended ASCII, which is what we usually think of ASCII as, is 8 bits, 256 characters. And Unicode is a 16-bit value, so it can hold 65,536 unique characters. All right, but all it is character 1 is this guy, character 2 is this guy, character 3 is this guy. It's a number that maps to a character. Why? Because computers like numbers. So we store numbers inside of our hardware registers, things like that on our CPU. And then at runtime, if those things are labeled as numbers that represent a character, we then go and look it up on either our ASCII or our Unicode table and come back with the letter or the symbol, whatever it is, whatever it represents. Okay? One of the candidates didn't know the concept of that at all. The other one danced around it pretty hard where we weren't sure. These are things you learned as freshmen in undergrad. These are people with PhDs. Disgusting. That's the world we live in. Okay. And these are younger people. Both of these folks were in their late 20s, something like that. Just got, fresh PhDs. This is what's happened to higher ed. Be the difference. You have to be the difference, especially you, Carnival. It's terrible. So, oh, and a little bit of you. Well, you're probably a lost cause.
So,
All right, so so anyways, then we had two programming questions. Programming question number one. Write a function that takes a string as a parameter and returns the first character in that string that doesn't repeat anywhere else in that string. So the first character in that string that exists one time only in the string. If every character in the string repeats, return not found or false or whatever. Is that something that is kind of a coding one level question? String manipulation stuff? Okay. First guy didn't even want to attempt the programming questions. Second person, and I had them turn their camera on and write, on Notepad to write it live. They should be able to write this live. If you have a PhD in computer science, you should be able to write this live. I mean, most of you are beginning programmers. Put it on the spot to write something quickly like that is going to be stressful and you don't have the reps in yet. But if given time, the question I just told you, you probably can answer, right? It's in your wheelhouse. Second person struggled with it, but ultimately I think got a reasonable answer. Second question. Write a function called isPalindrome, which returns true, takes a string as a parameter and returns true if that string is the same forwards and backwards, like the word race car. Spelled forwards and backwards that's a palindrome. And I defined what palindrome was. They didn't have to know what that word meant. False otherwise. You can disregard case sensitivity. First guy didn't even attempt it. Said he didn't prepare for freshman coding for a job that requires AI expertise and coding expertise. Because I'm not going to teach the coding classes forever. So I need people who can code. Second person did get it after some struggle, but I would expect a PhD level person to be able to just zip those out in no time. This is what we're dealing with in industry. This is why you're going to be able to go out and make the big bucks if you learn how to wield these weapons and keep the blade sharp. Because that's what happens. Disgusting. That was our first two. Next ones are on Wednesday. Let's see what happens. It was terrible. Oh, large language model stuff. So, what's the difference between ChatGPT, Gemini, and Claude?
makes them.
Okay, yeah. I mean, I think that's a good answer. Most of your answers are mediocre. Who makes them? Yeah, that's true. ChatGPT is made by OpenAI. Gemini, made by Google. Claude is made by a company called Anthropic. I like the name of that company. It's a fun name. Claude is kind of like the Apple of large language models. Much more closed system, things like that. I personally don't like them that much, but they're fine. I have subscriptions with all of them. And have they announced to the students yet the Boodlebox thing?
Yeah.
Okay, so I don't know if it's live yet. Can you log into it yet? Okay, so the university just so I'm on our AI whatever task force crap, and I'm a little bit torn on this product. So the product is called Boodlebox. Now it sounds kind of stupid, but it is an interesting idea. So Boodlebox comes with a pro level subscription to typically the latest model from ChatGPT. So right now, only 5.1 is available on there, when 5.2 technically is available from OpenAI. It does not have Gemini 3 yet. It has Gemini 2.5 Turbo. It does have the latest Claude. So bottom line is when you log into it, you get to pick which model you want to use. And now you're talking to that model and you have unlimited pro access to all the models. Um, but your memory interface is BoodleBox. So it's doing this through what's called API calls to that. So it's not necessarily when you have a long-term conversation with ChatGPT or Gemini, it gets to know you, right? Gets to know your writing style, gets to know kind of who you are or whatever. Or for those of you who have one subscription but share it with 11 buddies, it creates a conglomerate of the 11 CS student monster. Um, go ahead.
Is the university just gonna look over your shoulder to see everything you do?
Oh, no, because that's actually the reason we go with a place like Boodlebox. Because the only other one really from this list that would have been reasonable to consider is Copilot. And you have Copilot through our Office 365 subscription. Um, but Boodlebox is an enterprise solution for higher ed. So your data is private to you. University will not have access to your prompts and things like that because it's meant for doing research and things like that.
Like, the-
Yeah, you could potentially write a piece of software. I think when I asked them about API keys for them, it's something they said, oh, it's going to be available soon, whatever. But the idea would be if you had an API key, you can then write a computer program. I presume you would have an API key to Boodlebox. So you would talk to Boodlebox, and as your program is sending in a prompt, you would tell it which model you want it to use. And that's the way it already works. If you're using ChatGPT and you're writing code that talks to ChatGPT, it's a different subscription. So if you have ChatGPT Pro that you pay $20 a month for, that is different than having an account with their API side. API side, they have a credit card on file. You get charged per million of tokens. It's not a lot of money, but when you write that code, you have your API key. You say, I want to make this, I'm making this call to ChatGPT 5.2. That is going to be a more expensive call than if you do to ChatGPT 4.0 mini. Because you might decide, oh, well, 4.0 mini is good enough to solve the problem that I'm currently solving, whatever it is. But none of those are super expensive. But you will be able to do that with Boodlebox according to them. I haven't, doesn't, it's not live yet, but my understanding is that's how it will work. Yes, except you'll have to keep in mind that it's Boodlebox that has your memory, and I think it's probably only going to pick up your memory if you're interfacing directly through Boodlebox, just like ChatGPT. When I call something with a program on ChatGPT, it does not know my whole persona. So anything you want it to know, you're going to feed it as context to it. You have a huge context window with ChatGPT. So, I mean, you could give it a library of 400 pages telling you, I want you to write it in the style of the person who wrote these 8 books. And you can put the books in there and then ask your prompt, and it could work with that size of thing. All right. But anyway, so as we look at these, we have ChatGPT is OpenAI, Copilot. Who owns Copilot? Microsoft, but it's by way of OpenAI. Copilot's powered by ChatGPT. Gemini is Google. Claude is Anthropic. The other ones aren't actually Grok. Grok belongs up here. We'll call Grok a weak fifth, but Grok has actually become pretty popular in for certain tasks, and it's not as embarrassing as it used to be. And DeepSeek is the Chinese made one that is shockingly good for the amount of money they spent to do it, but in general, it's not considered trustable from conspiracy theory type stuff. Who knows? But now, what is the difference between ChatGPT and Copilot? So I've told you that Copilot is actually powered by ChatGPT. But why might you pick Copilot over ChatGPT? What does Copilot specifically give you? And the same answer is going to be true of why would you pick Gemini over ChatGPT if you like that question better, since you maybe view Gemini and ChatGPT at the equal level, where maybe you view Copilot as kind of something less. So re-answer the question or rethink about the question in terms of why Gemini over ChatGPT. And it has nothing to do with the results the large language model is giving you. Because I think this week, well, 3 weeks ago, I think Gemini 3.0 was considered to be the new best. And I think ChatGPT 5.2 has now slightly beat it on, by like 1 point or something like that. But, at this point where all these models are good. So why might you choose Gemini over ChatGPT? Anyways, if it's only second best. Go ahead. Okay. No. I mean, it could be a reason you do it. It's not the main reason. Go ahead.
Microsoft is integrated in Windows, the open thing is just there.
So that might be why you pick Copilot?
Yeah.
Is what you're saying instead of Gemini?
Go on the web, go to your browser, look up chat.
Okay, so convenient access. Okay. Could be a truth, not the main thing. Gemini is made by Google. How many of you have Gmail? How many of you use Google Docs? Gemini has access to all that. Gemini, your account with Gemini, has access to your Google ecosystem. So it's an integrated product. Not only can you ask it stuff about this, you can ask it to find the paper that you did on something or other, or summarize all the documents in this folder on Google Docs. It has all those things as part of its context. Same thing with Copilot. If you're a Microsoft shop and all your stuff is in Microsoft's cloud, Copilot has access to all that stuff. ChatGPT does not. ChatGPT is a separate standalone product, right? Now, some companies have started integrating ChatGPT into their stuff, so it does get context, but it's on a one-off situation. Claude has the same problem as ChatGPT. A little bit less popular, but it's a high-quality thing. Claude is actually considered to be strong for coding, is where it's claim to fame is, but frankly, they're all good at coding now. Doesn't matter. Grok, at the least, has the context of your X account, your Twitter account, whatever. Okay, so you get the point? So each of these solve the same problem, but some of them have a larger context. So I was mentioning what rolled us into this is I use an IDE called, do I have it open here? Here I have an IDE called Cursor. Oh, look at that guy. So this is my apologetic site. I'll put a link up to it. I write a bunch of papers on defending the Christian faith from a logical thinker's perspective. So I have papers on understanding Islam, understanding Hinduism, understanding atheists. Am I really a Christian? Is there a heaven? Is Noah's flood real? Things like that. But I approach it logically. It's not, hey, let me slap you across the face with a Bible. Now let's open up to Hebrews 3. Go ahead. It's called quantumdisciple.com. Yeah, so if you go here, quantumdisciple.com, and you go to papers, you can see here's the papers that are up right now. So this compares Hinduism versus Christianity, which is fascinating. Hinduism has a single God. It's not a zillion different gods. It's really pretty cool. Islam, Jewish, atheist. This one's really cool. Am I actually a Christian? You have 2.5 billion people in the world that identify as Christian. How many of them even know what they believe? They grew up in the church. They don't know any better. But the point of all my stuff is it's non-confrontational. Here's logic. This points, connects it to these different things. Whatever. If you go into one of these files, you can listen to the audio of it, but it's actually done as a script instead of just reading the text. So it's got all sorts of imagery and things like that for everything. It's cool. Feel free to check it out and give me any feedback you quantumdisciple.com. These last two are pretty cool. Is the Bible reliable or is evolution true? That's a good one too.
How much AI
Well, so I would say quite a bit of AI generating frameworks and stuff, but each one of these papers probably takes me 5 or so hours to create, because what I do is I give public speaking things on apologetics, because I think that's where my strength is in delivering stuff. Writing is more of I go and research these things, I learn about them myself, and then I put them into a format. So a lot of it might be here, I write something, I give it to AI, and I say, help me fact check this. Let's make sure these things are biblically accurate and things like that, and say this in a way that fits a persona. So I've created a persona. So I'm leveraging, I use Gemini for this writing. I think Gemini writes it better. I have created a persona that speaks a certain way. And I give it the facts that I want to create into that persona, and then it generates the persona text for me, and then I go through and clean it up as I want. But in any case, here is Cursor. So Cursor over here has this big thing where it is I can type over here. So you can choose the model it's support here. It has GPT 5.2. It has Claude Sonnet, Claude Opus. It has actually some pro ones for doing more powerful things if you're doing it. But in any case, it has a lot of here's Grok code. It supports high-end things. I pay for this guy. But when you're operating over here and you're typing something in, it has the context of your entire folder. So I can say, update the site to have a Fruit Loops theme. And it will go through the entire folder and update all the HTML documents to do that. Now, that is something, hey, it's cool, it's convenient, but I rarely use that feature. I might only use that for my very first prompt to give me an initial project skeleton. After that, I go into individual files. So for instance, if I go into this one, and this is just HTML stuff, and let's say I come to this line right here, and I want to insert something right here, I might say, add a line that has hello world in giant bold font right here. I do that, it's going to go and create it for me. So here's that line right here, hello world. It put it all in the right bold size, all that stuff for me. I use it like that, targeted in a very specific part of the code. Otherwise, if you are operating off of this thing over here, which is using your entire thing in context, then it might change files you had no intention of changing. I've seen entire people's projects just almost get wiped from relying on it too much. This is the problem. And you probably have seen some students who have, or maybe some of you yourself, have used tools like this to generate an iPhone app, right? Or generate a nice looking website. And in your mind, you're like, oh, I'm a programmer now. You have a false sense of competency.
as opposed to wielding this power tool. This is a microwave oven to a programmer, to a chef, let's say, whatever. Okay. A programmer can use something like this to save themselves tedious time. And then they go in and either write the specific code for certain problems, or they deliver a very, very, very targeted prompt explaining how I want this problem solved exactly, and then let it generate the code, because you know you could write the code yourself. That's a benefit of using a tool like this. So don't judge your outputs as evidence of your competency. Those are not related. Make sense? But these are cool tools, and this is an example of something similar to Gemini or similar to Microsoft's Copilot. It's similar to all those things in that it has context of larger pieces of information. I think Replit has its own AI thing that will do something kind of similar to this. There's 4 or 5 other ones out there. They're cool. You know, I'm not saying avoid using it. It might, you know, you could maybe use something like that to generate a quick website for like flashcards to study for an exam. I mean, it's legitimately a power tool. Just don't treat it like I now know how to do this on my own. You know, you want to learn how to do it on your own first, because then behind the scenes of this, every time I make a change, what do I have to do? Well, I secure copy this up to my server. Then I have to SSH into the server. I have to change the permissions. Now you got to know how to use Linux. You got to know how Apache works on Linux. There's all sorts of technical skills here that it might generate a whole bunch of code. Now you don't know what to do with it. All right. Don't skip those pieces of things. So these large language models are not replacing us as programmers. These large language models are giving us power tools that we will appreciate as we become better and better and better programmers. Okay, don't let it get in the way of your problem solving. All right, so we were talking, I know we have, what, we're at 9:20? Okay, so just in the last minute here, we'll pick up where we left off next class. It's my hello world. All right, so we have this low-level language here, and the question we were addressing is why does a compiler need to know about the architecture, the processor you're targeting, as well as the operating system you're targeting? Anybody have an answer for me for that? Why does it need to know both? You already told me that a compiler takes high-level code and turns it into low-level code like this. I think I had left you with that missile code thing, right? When you compile C#, it turns into Missile, Microsoft Intermediate Language, which is the same as Java bytecode. And ultimately, when you run your .NET program for the very first time, it takes a little bit longer to run, because what it does is it further, it's actually not a compiler because it's low level to low level, it converts Missile code into an executable software for that processor. So it'll run fast from the second time on. Well, it'll run fast the first time. It just might take a little longer to start because it's doing that final mile, turning it into actual executable code for the hardware. But why does it need to know both things?
Operating system, different operating systems have different level code, or you need different level code to do the same thing.
Okay. I think you're thinking about it correctly. Different operating systems. So for example, if you want to display something to the screen, syswrite is what it is on Linux. Every mainstream every operating system that you might ever run into, doesn't matter which version of Linux or whatever, they will have some built-in system call that knows how to write crap to the screen. But the mechanism by which you call upon that system call might require different low-level instructions. So the compiler needs to know not just your processor, but what operating system are you retargeting? Because I'm going to leverage that operating system. Okay, so we'll start off there. I'll walk through this again next class. So let me just say, start with walk through the Linux hello world. then get on to recursion. All right, I'll put up the a link to the slides as well as a link to the videos on YouTube. We'll continue on this conversation on Thursday morning. Questions, comments, concerns, bribes? I am heading down to chapel front row. You are welcome to join me. It's got plenty of room in the front row too. It's great. What's up?